Good morning. I'm moving on, still on the same paper. I'm moving on to another fluvial landform. That is your delta. I'm moving on to another landform. That is your delta. Today I'm working on geomorphology. Okay, so delta, the first thing that you need to understand is what is a delta. You need to understand what a delta is. You need to understand what is a delta is, and also where is it formed. So I'm gonna do it this way, okay? I'm so in love with the profile of a river. This is the source, this is the mouth, this is the upper, middle, and lower course. So you need to understand, where do we usually find this delta? You can see here, you can see here, this is your what? This is your delta. It's close to the mouth of the river, which means you find it in the lower course of the river. You find it in the lower course of a river. That's what should guide you. So which means your delta, you find it in the lower course of the river. This is where you find your delta, in the lower course of the river. Okay, that's number one, which means there is more deposition in the lower course. I want to help you there. There is more deposition in the lower course of the river. So already you have an idea where are you likely to have this delta. It's a depositional feature that is found in the lower course of the river. Okay, and also in terms of how it looks like, it's triangular. You can see it's a fan-shaped, like created through deposition of sediment at the mouth of the river. So you can explain it by describing what it looks like. It's fan-shaped, okay, deposition of feature that is found at the mouth of the river, that is the lower course of the river. Of course, these are some of the things that you can actually see. So what we have from this delta, we have got what we call the distributaries, which are the streams that are flowing away from the river towards the mouth. They do not rejoin to the mainstream. That's why we call them distributors. So when you talk about delta, please, we don't talk about tributaries, we talk about distributors, which are streams that flow away from the river towards the mouth of the river. It can be the sea, it can be the lake, okay, it can be the ocean. They do not rejoin the river. That's why we call them distributaries, okay, which means all these are distributaries. All these are distributors. They're flowing away from the mainstream towards the mouth of the river. They do not rejoin the river. That's why we call them distributors. That's why we call them what? Distributaries. Of course, you can see also that there is deposition that is taking place here. There is deposition that is taking place, which shows that the river has lost most of its energy. It starts to deposit, okay, some materials because it has lost most of its energy. So this is within the lower course of the river. This is a depositional feature that is fan-shaped as a result of a river losing energy on the mouth of the river. That's what a delta is all about. That's what a delta is. Okay, let's go through the question now. The first question reads, what is a delta? Which means here we are defining what it is. We are defining what it is. We are referring to the scale. So you can define just by describing what you can see here. Fan-shaped depositional feature that is found at the lower course of the river. I'm just using what I'm seeing here, okay? But you define it as a landform that is triangular or fan-shaped, like created through deposition of sediment at the mouth of the river. That's what this is all about. So explain it by describing what you can see there if you cannot recall, okay? Then identify the river course where deltas form. I've already said this is the lower course of the river. Lower course of the river. This is where it formed, at the lower course of the river, where there's more deposition. Then describe how deltas form. You are now describing how are deltas formed, okay? When the rivers approaches the ultimate base level at its speed, energy is reduced, okay? The river is unable to transport its load and deposit sediment at the ultimate base level. This is what is happening at the lower course of the river. Flotation of clay materials and sediments due to saline conditions. The sediments, deposit material, spread outwards from the mouth, gradually accumulate and rise above sea level. The slow velocity of water leads to the formation of distributaries. So basically what we are saying now is at the mouth of the river, what's happening is the river has lost most of its energy. Once it has lost most of its energy, what happens? It starts to deposit materials. Are we together? It starts to deposit materials. But however, as the river is flowing now, which means what has been deposited now, we have got multi streams that are flowing towards the sea, the ocean, or the lake. But as they are flowing, obviously you can see more like the sand island. You can see what is happening here. Multi streams, which are distributaries, are formed as it actually approaches the sea, the land, or the mouth of the river. So when the river approaches the outlet base level of speed, energy is reduced. That's number one. There's deposition now because in the lower course, the river has lost most of its energy. In simple terms, the river is not able to transport its loads. Then what does it do? It starts to deposit these sediments. Okay, it starts to deposit these sediments. Okay. The sediment deposit, what does the sediment deposit do? What they spread outwards from the mouth. So it means the sediments that are deposited now, they're spreading outwards from the mouth. Okay. Spread outward from the mouth. Okay. And gradually accumulate. They gradually accumulate. Obviously, some of them I have, they're gradually accumulating, of course, above sea level. And the slow velocity of water leads to the formation of distributaries. That's why we have got this, that is showing small distributaries. Of course, they have accumulated, then you've got these small streams that are called distributaries at the mouth of our river. Then you get your 4 marks. Okay. In a paragraph of approximately 8 lines, explain the importance of deltas on human activities. You can see now how they want to ask how it can actually, the significance or the importance of deltas. What do we have there in as far as deltas are concerned? Number one, obviously, we are saying that there's deposited material, which means there are higher chances of fertile soils. So it contains fertile soils for agriculture. That's number one. When you talk about deltas, they've got fertile soils for agriculture. That is the importance in as far as humans are concerned. So there's fertile soils, which means it favors agriculture or farming for humans. Okay, so that's a benefit, which means we are able to get income by farming on these deltas because they've got fertile soils. Okay. It's good for construction of towns and cities. Okay, it's good for constructions of towns and cities. Habitable by humans, can be used to build settlements. Those are some of the things that you can actually talk about. Habitable for humans, can also be used to build settlements. It's close to water source for irrigation. You can see it's close to the water source for irrigation and hydroelectricity generation. What else can you talk about? Can be used for bulk transportation of goods. It promotes aquaculture, which is fish farming. Provide water for domestic activities. It contains large mineral deposits. So those are the benefits. When you talk about aquaculture, that is fish farming. So it promotes fish farming, which is aquaculture. Okay. Or in general, aquatic, we have got different forms of life that you find within the marine ecosystem. So aquaculture, of course, fish farming is a form of aquaculture. That's what we call about it's fish farming. Okay. So this takes us to the end of this fluvial landform. That is your delta. Thank you so much.